Good morning, dear students. Today is 24th of March 2021. My name is Ferhan Mazher, and right now we are studying the subject Physics 5054. And today we have set our hearts to solve October-November 2015 1-1 paper. It's an MCQ paper and it's from the Zone 1. So let's start this paper. And so here we come. You see October, November 2015, 1-1, Physics 5054. Here we come. The first question on your screen. During an experiment to find the density of a stone, the stone is lowered into a measuring cylinder partly filled with water. Which statement is correct? So it's a measuring cylinder. So you see you have water in the measuring cylinder and then you lowered a stone into the measuring cylinder. The level of the water will rise, the volume of the water will increase. So if the first volume is V1 and the second volume when the stone is inside the measuring cylinder, if you call it V2, so if you subtract V1 from V2, V2 minus V1, that will give you the volume of the stone. His statements are, which statement is correct? The difference between the readings gives the density of the stone. No, it do not give you the density of the stone. The difference between the readings gives the volume of the stone. Yes, this is the answer. This measuring cylinder, the two readings which you get, if you take their difference, this will give you the volume of the stone. So I think question number 1, B is the right choice. Okay, on your screen, we have the next question. It says the diagram shows a micrometer scale. Which reading is shown? Okay, so let me increase the size so you can see it more clearly. So here we go. Now you can see, first of all, we will check what is the reading on the on this horizontal scale. So I can count, you see, this is 0, this is 5, so it means 1, 2, 3, 4, 5, 6, 7. So 7 on the horizontal scale, this circular scale has crossed 7, and this is 7.5. So on your copy, note down 7.5. Let me write it here. Let me write on the page. So I will write 7.5. So the reading is 7.5 millimeter. Your circular scale has crossed 7.5 millimeter on the horizontal scale. So after that, I will check which line on the circular scale coincides with this horizontal line. So this is 10, 11, 12, 13, 14. So the 14th line is coinciding with the horizontal scale. So on my rough paper, what I will do, I will add 0.1 and 4. So the final answer should be 7.64. So you see, the final answer will be 7.64. 7.64. Let's reduce the size. So do we have that answer here? Let me check. In the option 7.64, D is the choice. Let me check the answer from the marking scheme. Yes, sir. D is the choice. Question number 2, D is the choice. I hope you have understood that how we have done this process. Okay. Next, we have question number 3, which is showing on your screen. An object travels at constant speed of 10 meters per second for 10 seconds. During the next 5 seconds, it accelerates uniformly to 20 meters per second. What is the total distance traveled by the object? On your screen, you can see that we have a speed time graph. And on the y-axis, the speed is represented, and on the x-axis, the time is represented. So if you have a speed time graph and you want to find out the distance traveled, so the method is you find the area under the speed time graph. The area under the speed time graph represents the distance traveled. So I have done this on a paper. So you can see here we have a speed, here we have time. This is the speed time graph. So I will divide this into two portions to make it easier, to make the calculation easier. And I will calculate the area of these two portions, and then I will add them. That will be equal to the total distance traveled. So for example, I have done this on a paper also. Let me show you. So here you can see that I have tried to make that diagram again, and I have divided that speed time graph into two portions. This first portion looks like a rectangle, and this second portion looks like a trapezium. So I will find their area. The total area will be the area 1 plus the area 2. This rectangle will be length multiplied width. Its length is 10, its width is 10. So 10 multiplied 10, 100. The area 1 will be 100. Area 2, which is a trapezium. If you want to find out the area of a trapezium, the formula is very simple. 1 by 2 into height into sum of parallel sides. So this is the height of the trapezium, that is 5. One parallel side is of 10, the other parallel side is of 20. You just put the values. So it will be 1 by 5, 1 by 2 into 5 into 10 plus 2. So you get 75. You add them, 175 meter. So have a good look on this slide. I hope that you have understood that how this is done. Area under the speed time graph is equals to the distance traveled by the body. So hope you have understood this. So 175 is the answer. So we look in the options. Yeah, B is the option, 175. For question number 3, B looks the right answer. Let me check from the marking scheme. Yep, B is the right answer, sir. So we will go to the next question. Here we come. Which object has the largest resultant force? And okay, so you can see here there's a force applied. Let me copy it from here so I can explain it to you. And we paint it in the. We will paste it in the paint, and we'll see where the resultant is the largest. Let me take it. Let me take this thing into the paint. Okay. Here we go. Let me take a new one. Now paste. Okay. So you can see here there 20 Newton force is towards the left and 30 Newton force is towards the right. So the resultant will be 10. In this diagram, 20 Newton force to the left, 10 Newton force to the right. So the resultant will be 10 Newton towards the right side. Here in the C diagram, 10 Newton force is towards right and 30 Newton force is towards left. So the resultant here will be 20. So here the resultant will be 20 towards the left side. In this diagram, all the forces are towards the left and their resultant will be 15 Newton. And that will be towards the left. So the question was, I think where is the greatest, what is the largest, the question was what is the largest resultant force. So the largest resultant force, I think you can see that is the C choice. C is the right choice, sir. It has the largest. It has the largest resultant. In which example does friction act in the direction of the forward motion of the object on which it acts? On a suitcase accelerating on a conveyor belt, on sandpaper rubbing a wooden block, on the skis. Let me change the size a little bit so you can see it more clearly. On the skis of a skier accelerating downhill on smooth surface, on the tires of a braking car. Okay. So let me show you my work. I've done this. I have just noted down the, yeah. Okay. So on your screen, you can see here, I have tried to show a conveyor belt. You see conveyor belt is moving towards right. I just trying to explain you how this, how is this answer. A conveyor belt which is moving towards right side. And on the conveyor belt, we have put a bag. You see the bag is moving with the conveyor belt. Bag relative to the conveyor belt is not moving. So the bag is on this point of the conveyor belt. So relative to the conveyor belt, the bag is not moving. The bag is on the conveyor belt and the conveyor belt is moving like this. If this is the bag and it is moving, the conveyor belt is basically moving. The bag is on the conveyor belt, so it's moving with the conveyor belt. But relative to the conveyor belt, it's not moving. So you see the bag is basically also going to the right side. The conveyor belt is also going to the right side, but relative to the conveyor belt, the bag is not moving. Bag is going towards the right side. The conveyor belt is also moving to the right side. So the bag will have inertia. The bag will have inertia. The inertia will try to pull it backward. The inertia will be trying to pull the bag towards the left side. So the inertia will be trying to stop the motion of the bag. So inertia is trying to pull it backward, and because the inertia is all the time acting on the bag, but the bag is going with the conveyor belt. So bag is trying to fall towards the left. But the friction between the bag and the surface of the conveyor belt, it will be not it is not allowing the bag to fall backward or to fall towards the left. So the friction will be towards right. So the friction between the surface of the bag and the surface of the conveyor belt will be towards the right. So you see here, the conveyor belt is moving towards the right. The bag with the conveyor belt is going towards the right, and the friction acting on the bag and acting between the bag surface and the conveyor belt surface, that is also towards the right. And the reason is it is trying to oppose the force which is produced by the inertia. Remember one thing, the bag is not moving relative to the conveyor belt. It's very important thing. So this is the answer actually. Question number 5A is the answer. The rest of the things, they are wrong. On a sandpaper rubbing a wooden block, when you rub a sandpaper on a wooden block, the direction of the friction will be opposite to your stroke, or opposite to in which whatever direction the sandpaper will be moving. On the skis of a skier accelerating down the hill, if the skier is coming downward, so the friction will be opposite to his motion. On the tires of the braking car, in the braking car, if the tires are jammed and the brakes have already been applied, the friction is opposite to the motion of the car. So A is the right choice. Question number 5, A is the right choice. You see, this is not an easy question to answer. It's a bit difficult. So here we have question number on your screen. That question, let me show you the full question. Okay. The diagram represents the moon in its orbit around the earth. Which arrow represents the direction of the resultant force acting on the moon at the instant shown? You see, the moon is moving in a circular track, in a circular path around the earth. And you know, whenever a body moves in a circular path, a centripetal force acts on it. The direction of the resultant force is always towards the center of that circle. So I think the resultant force should be A. Which arrow represents the direction of the resultant force acting on the moon at that instant? The direction of that resultant force should be A, towards the center of that circle in which the moon is traveling. So A is the choice. Marking scheme also says A. Question number 6A is the right answer, sir. So on your screen, we have question number 7. Which statement about mass is correct? Mass is density divided by volume. That's wrong formula. Mass, correct formula is density multiply volume. Mass is the amount of space occupied by a body. That is called volume, not the mass. Mass is weight multiplied by the gravitational field strength. That's wrong formula. Mass is equals to weight divided by the gravitational field strength. These mass resist a change in motion. Yes, that is the right answer. We call it inertia, the property of the mass due to which it resists a change in its motion. That's known as inertia. So mass is basically mass resists the change in motion, inertia. So D is the correct option. D is the right statement. So question number 7, D is the right option. So let's move to the next question. So here we come on your, sorry. So on your screen, the total weight of the load and the wheelbarrow shown is 600 newtons. So you see it's this wheelbarrow. So what happens, these wheels, the pivot is here. Here in the center we have the load, and from this handle the labor will try to pull it upward. So this load, the weight of the load is 600 newton, and if this is the pivot, this 600 newton force is trying to produce a clockwise turning effect, and the force you applied here and the pivot is here, the force which labor will apply in upward direction to move this wheelbarrow, that force will produce an anti-clockwise turning effect. And you know, if this is the pivot, this 600 newton force, the moment arm or the perpendicular distance between the pivot and the line of action of this weight is 70 centimeter. And the moment arm of this F, the pivot is here, the moment arm of this F, or you call it the perpendicular distance between the line of action of the force and the pivot, is 120 centimeter. So we will use the principle of moments that says the anti-clockwise moment is equal to the clockwise moment, and we will put these values, and very easily we can find out the value of the F. Let me show you my work. I have done this on a paper. Okay, so I have made that diagram little easier for you to understand. So on this left end we have the pivot. Here somewhere a 600 newton load. It was 600 or it was 6,000. Let me check again. Maybe 600 newton. Okay, so we are good. So you see, so in the center somewhere there is a weight of 600 newton which was acting downward. This weight is trying to produce a clockwise moment, and on this right end the labor will apply force in the upward direction, and that force is questioned to us. We want to find out that force, and its distance from the pivot is 120 centimeter. Clockwise moment is equal to the anti-clockwise moment. 600 multiply 70 equals to F multiply 120, and F, if I make the F alone, 120 will go on the other side and it will divide there. So it will be 600 multiplied 70 divided by 120 equals to 350 Newton. So the force F will be 350 Newton. I hope that you have understood this calculation, and the answer is 350 Newton. Let's check the options. Yeah, A is the option, sir. Question number 8, 350 Newton. A is the right option. Question number 8, the marking scheme says question number 8, A is the right option. So hope this you have understood this question. Okay, question number 9 is on your screen. A force acts on a body. Which properties of the body may all be changed by the force? When you apply a force on a body, you can change its shape. By applying the force, you can change the shape, you can change the size, you can change the volume, you can change the velocity, you can change the direction of motion. One thing which you cannot change by applying force is the mass of the body. So his question is, which property of the body may all be changed by the force? D is the right option, shape, size, and velocity. All A, B, and C cannot be the option because they include mass. Mass is one thing which you cannot change by applying a force. So that was question number 9. D is the choice. My marking scheme says D is the right choice, sir. Here we go. Some students plan to use a spring to make a spring balance with a linear scale. The graph shows how the extension of the spring changes with the load on it. What is the total range of balance with a linear scale using this spring? You see, up to which load the graph is a straight line. For example, if I look at this line, this diagram carefully, let me increase the size so you can see this. Okay. Now on your screen it's very clear. Up to 10 Newton, the graph is a straight line. Up to 10 Newton, graph remained straight line. After 10 Newton, the graph became a curve. So it means up to 10 Newton, the load and the extension, they are directly proportional to each other. So up to 10 Newton. So the range can be from 0 to 10 Newton. The range can be from 0 to 10 Newton. The question was, what is the total range of a balance with a linear scale using this spring? If you want the scale to be linear, up till 10 Newton, the thing was linear, the spring was linear, the extension and the load, they were directly proportional to each other. But after 10 Newton, the graph is no more a straight line. So the range will be from 0 Newton to 10 Newton. So A looks the best option. Question number 10, A is the best option, sir. Question number 10, A is the best option. A block of weight 900 Newton has a rectangular face. The diagram shows the length of the side. So you see, this is a rectangular block, and you know the rectangular block has 6 faces, and the dimensions of that rectangular block are given. The length is 0.50 meter, the width is 0.40 meter, and the height of the rectangular block is 0.30 meter. The block can rest on any of its faces. What is the minimum pressure that the block can exert on the ground when resting on one of its faces? You know the pressure is equals to weight divided by contact area. Pressure is equals to weight divided by contact area. So the weight of this block, whether to put it like this or you put it like this or you put it like this, on whatever face you put it on the ground, the weight will remain the same. So the pressure, because the pressure is equal to weight divided by area, the pressure can be minimum if the contact area is maximum. The pressure can be minimum when the contact area with the ground is maximum. So I will take that face whose area will be maximum. Let me show you. I have done this on a paper. So here we go. So the the minimum pressure will be equals to weight divided by the face with the largest area. So there are 3 faces. Basically, there are 6 faces, but each 2 are same. So one face is, its length is 0.50 and the width is 0.30. So multiply them. The area will be 0.15, and another face is 0.40 multiply 0.30, and its area will be 0.12, which will be the least area. And then another face is 0.50 multiply 0.40, and its area will be 0.2. So that is the largest area. I told you that the minimum pressure will be weight divided by the largest face, the area of the largest face. So it will be 900 divided by 0.2, and it will be 4500 Pascal. 4500 Pascal will be the minimum pressure. 4500 Pascal will be the minimum pressure. So hope you have understood 4500 Pascal. So the choice question number 11, B is the right choice. I'm looking at the marking scheme. B is the right choice, sir. Question number 11, B is the right choice. You see, we never attempt any question whose marking scheme we don't have. It's very important for us to have correct concepts, and for that reason, a very thumb rule is that we never attempt any question whose marking scheme we don't have. Okay, a U-tube containing water is used as a manometer when one end of the manometer is connected to a low pressure chamber. Both water levels in the manometer change by 20 centimeter. The gravitational field strength G is 10 Newton per kg. The density of the water is 1000 kg per meter cube. How far below atmospheric pressure is the pressure in this chamber? So try to understand this. Let me increase this diagram so you can understand this. Okay, so here we have the low pressure chamber, here we have the atmosphere, and you see this manometer, it has two limbs, and in both the limbs the level of the water is different from each other. So I am basically interested, what is the total difference in the levels? 20 centimeter here, 20 centimeter here. So the total difference between the levels of the water in both the limbs is 40 centimeter. So the pressure, this gas, this side is open to the atmosphere, which and this side is open to a low pressure chamber. So it means that the pressure of this this chamber, the pressure is very low. The atmospheric pressure is larger. But how much it is lower? It is 40 centimeter of water lower. But he wants you to convert this into Pascal, I think. Let me check the, yeah. He wants the answers to be in the Pascal. He wants the answers to be in the Pascal. So, and we have to tell how below this is from the atmospheric pressure. So it is in centimeters, what I will say, the pressure chamber, the pressure in the gas pressure chamber is 40 centimeter of water lower than the atmospheric pressure. So now I will convert this into this thing into pascals. The formula is, the pressure is rho GH. The formula for the pressure of a liquid is rho GH. So I have done this on a paper. Let me show you my work. So you can see on your screen we have this slide. Pressure is equals to rho GH, where rho stands for the density and G stands for the value of the gravitational field strength, and H stands for the length of the column of the water. So rho 100 into 10 into 40 divided by, why I divided with 100? Because that 40 was in the centimeter. So I will convert it into meters. So centimeter, if you want to convert them into meters, you have to divide with 100. So when you do this calculation, 4000 Pascal. So the pressure in that gas chamber is 4000 Pascal less than the atmospheric pressure. Let me check. 4000. Do we have this answer here? Yeah, it's B choice. So B looks the right option, sir. You see, question number 12, B is the right answer. The marking scheme also says B. Question number 13. A gas is trapped inside a cylinder by a movable piston. The length of the gas column is 20 centimeter and the pressure inside the cylinder is P. The piston is pulled out a distance of 30 centimeters so that the length of the gas column is now 50 centimeter. The temperature of the gas does not change. What is the new pressure of the gas? Okay. When the piston is here, the length of this cylinder in which we have the gas, that will be 20 centimeter. And when you pull this piston backward, when you brought the piston here, the length of this cylinder in which we have the gas becomes 50 centimeter. So the length here is 20, the length in this situation is 50. You know the cross-sectional area, in both the cases remained same. So the cylinder has the same cross-sectional area. Whether the piston was here or the piston was here, the cross-sectional area in all the situations is same. The cross-sectional area has not changed. So it's very simple. You know the volume is equals to cross-sectional area multiply the length. Volume is equals to cross-sectional area multiply length. The volume of a cylinder is cross-sectional area multiply length. So I've done this on a paper. Let me show you my work. I hope you will be able to understand it. So famous formula when the temperature do not change, P1 V1 equals to P2 V2. P1 V1 equals to P2 V2. In the first situation, the pressure was P. The length, I have V1 in the place of V1, I have put length into the cross-sectional area. That's the volume. So it will be 20 multiply area equals to P2 is the question, and the V2 will be the length multiply cross-sectional area. That will be 50 multiply A. So if A and A will be cancelled from both the sides, P2 will be equals to 20P divided by 50. So 0, 0 cancel, it will become 2 by 5P. 2 by 5P means 0.4P. So the value of the P2 will be 0.4P. P2 will be 0.4P. I hope that you have understood. 0.4P. Let's check the marking. Let's check the options. Oh, A is the right answer. 0.40P. A is the right option. Let me check the marking scheme. Oh yes, the marking scheme says A. Question number 13. A is the right option. So the next question on your screen. Yeah. The input power to a lamp is 6 watt. The lamp wastes 2.7 joule of energy in 3 seconds. What is the efficiency of the lamp? The input power of the lamp is given, the time is given, the wasted energy is given. We want us to find out the efficiency of the lamp. The efficiency of the lamp is the useful output energy divided by the total input energy multiply 100. In this case, you don't have to multiply with 100 because in fraction he is going to give us answer. In decimal fractions they gave the answer. So here it comes. So on your screen, I think you can, it's visible to you. Input power is 6 watt. Input energy will be power multiplied time. The power is 6 watt and time is 3 seconds. So it will be 18 joules. So wasted energy they gave in the question, that is 2.7 joules. So from the input energy minus the subtract the wasted energy, you will get the useful energy output. The efficiency is useful output energy divided by the input energy. So that will be 15.3 divided by 18. And our final answer for the efficiency will be 0.85. Efficiency is 0.85. I hope that you have understood this. 0.85. Efficiency is 0.85. So it looks D is the right answer. D for question number 14, D is the right answer. Marking scheme also says D is the right answer, sir. And I hope that you have understood this. Okay. The diagram represents four thermometers. Which thermometer has the greatest sensitivity and which thermometer has the greatest range? Let me increase the size so you can also see. Okay, let me copy it from here and take it into the main. So let me find out the value of the, you see here the four thermometers are given. Let me find out the range for each one of them. So this goes from 0 to 25, so its range will be 25. Okay. This goes from 30 to 40, so its range is 10. This goes from 0 to 250, so its range is 250. This goes from 100 to 300, so its range is 200. So we are looking for the most sensitive. This is 200. Very difficult to write 200 with the mouse. So what was the question actually? Let me check the question. Greatest sensitivity and the greatest range. The greatest range here, the R has the greatest range, and the greatest sensitivity will be in that thermometer, because all the thermometers, they have the same length. They have the same length. All the thermometers have the same length. So the greatest sensitivity will be in that thermometer, which will have the smallest range. So this has the biggest range. The range is here. The biggest range is here, and the biggest sensitivity will be here. So the most sensitive will be Q, and the greatest range will be R. Let me check the answer. The greatest sensitivity, that will be Q and R. So C. This is the answer. Let me reduce the size so you can see the whole question all together. So the most sensitive will be because they all have the same length of the thermometer. So in them the comparison is easy. If the length of the thermometers is same, then the sensitivity can be compared easily. The one which has the least range will be the most sensitive. So for question number 15, C is the right answer, sir. Let's go to the next question. That is question number 16 on your screen. Which type of thermometer is used for measuring the temperature above 1000 degrees centigrade, and which type is used for measuring the temperature that change rapidly? The temperature which are more than 1000 degrees centigrade, the thermocouple will be the best thing to use. And if the temperatures are changing rapidly and you want to measure them, you want to record them, and the thermocouple will be the best thing. So I think D is the best option, sir. Question number 16, D is the right answer. Question number, we have 17. So you can see question number 17 is on your screen. An electric shower takes cold water at 17 degrees centigrade. The initial temperature of the water is 17 degrees centigrade. The shower gives 600 joules of energy every second to the cold water and heat it to 37 degrees centigrade. So the final temperature of the water is 37 degrees centigrade. So here we have a change in temperature. The from 17 degrees centigrade, the temperature went to 37. So approximately there is a 20 degrees centigrade rise in the temperature. The specific heat capacity of the water is 4200 joules per kg per degree centigrade. What is the mass of hot water supplied by the shower in 1 second? So the mass is basically the question. If you look at here, the unit used for mass is kg. Remember this thing. I've done this on a paper. Let me show you my work. So here we go. And let me sign. Okay. So on your screen, initial temperature is 17 degrees centigrade. The final temperature is 37 degrees centigrade. Change in the temperature will be 37 minus 17. That will be 20 degrees centigrade. The heat supplied is 6000 joules. The specific heat capacity, that is 4200 joules per kg per degree centigrade. Whenever there is a temperature change, the formula for the heat is mc delta theta. Heat is equals to mc delta theta, where m, if you want to find the value of the m, c and delta theta will go on the other side and they will divide on the other side. So just put the value 6000 divided by 4200 divided by 20. Just enter this in your calculator and you will get the final answer, 0.7143 kg. 0.7143 kg. 0.7143 kg. Let me check the marking scheme. Okay, here we go. So C looks the right answer, sir. Question number 17, C is the right answer. C looks the right answer. Question number 18 is coming on your screen. What is the latent heat of vaporization? What is the latent heat of vaporization? The energy required to make molecules expand. Remember, the molecules do not expand. The energy required to make the molecules expand and move apart. Molecules do not expand. The energy required to make molecules move apart. Yes, this can be the answer. And the D choice is the energy required to make the molecules move faster. You see, if the molecules will move faster, their kinetic energy will change. If their kinetic energy will change, it means that the temperature has changed. During the latent heat, during the state change, the temperature do not change, the speed of the particles do not change, the kinetic energy of the particles do not change. So D cannot be the answer. C looks the best option. C looks the best option, sir, here. Question number 18, C is the best answer, my dear students. So here we go. We are moving to the next question. It is, let me reduce the size a little bit. Okay. So we have here, okay, in an experiment using a ripple tank, plane wavefronts arrive at a plane surface. Okay. Oh my. In an experiment using a ripple tank, plane wavefronts arrive at a plane surface. Which row correctly describes the waves after they are reflected from the surface? When they are reflected, when the water waves are reflected from a surface. When they are reflected, I'm using the word reflected. When they are reflected, their frequency do not change. Their wavelength do not change. Their speed do not change. Only the direction of their wavefronts changes. Only their direction changes. And I'm talking about the reflection of the water waves. I'm not talking about the refraction. I'm only talking about the reflection of the water wave. So what happens? The speed of the wave will remain the same, and the wavelength will also remain the same, and the frequency will also remain the same. Only the direction of the wave fronts will change. So, which row correctly describes the waves after they are reflected from the surface? The speed of the wave should be the same, and the wavelength should also be the same. So I think D is the best option, sir. Question number 19, D is the best option. The marking scheme also says D. I hope you have understood. Question number 20 is on your screen. Let me increase the size so it becomes more clear. Which statement about the red light and the blue light is correct? Okay, if you remember those code words, the code words are very simple. Let me. What are the code words? The code word is Roy G Biv B I V. Roy G Biv. Roy G Biv means red, orange, yellow, green, blue, indigo, violet. Roy G Biv. Red, orange, yellow, green, blue, indigo, violet. So when the spectrum is formed, this is the order of the colors in that spectrum, and you can see this is the order of the colors in the spectrum. And when you move downward in this order, the frequency will be going increasing. So it means that the blue or the violet will have more frequency as compared to the red. But if you go down in this order, when you go down, the wavelength decreases. The lambda value or the wavelength will decrease when you go down. It means the violet will have less wavelength as compared to the red. So this is the behavior of the light and the colors of the light. So don't ever forget this behavior. Okay, I hope I have made my point clear. So let us look at the question that he says, which statement about the red light and the blue light is correct? Red light has a higher frequency than the blue light. That's wrong. Red light has a longer wavelength than the blue light. That is right. 100% right statement. Okay. Red light has the same speed in the glass as the blue light. In the glass, they have different speeds. The red will have a different speed. The blue will have a different speed. That's why when they enter into the glass prism, they split. They become separated. Red light is refracted by a glass prism more than the blue light. That's wrong. Blue is banded or refracted more. So B is the right choice, sir. Question number 20 to 20. Only the B is the best option. The marking scheme also says B. So let's move to the next question. Let me reduce the size a little bit. Yeah. So hopefully now this is visible on your screen. A ray of light in a transparent medium of refractive index 1.8 is incident on the surface as shown. The light enters air. So the light is basically traveling in some medium, and then a transparent medium whose refractive index is 1.8, and the light is going to enter into the air. Air will be relatively rare medium. So light is basically entering from a dense medium into a rare medium. And you know, whenever the light, and this is the behavior of light. Remember, this is the behavior of light. When the light will enter from a dense medium into a rare medium, it will bend away from the normal because its speed increases. When the light enters from a dense medium into a rare medium, for example, from this glass into air, the speed of the light will increase. The light will bend away from the normal. The angle of incidence in the dense medium is 30. So I will use the formula n is equal to sine I by sine r. But remember, whenever you write this formula, sine I by sine r, n equals to sine I by sine r, the formula can be both ways. It could be either n equals to sine I by sine r. It can also be n equals to sine r by sine I. So out of these two, which you will take? Remember as a thumb rule that the angle, whether it is angle of incidence or whether it is angle of refraction, whichever angle is in the rare medium, that should be in the numerator. Sorry, whichever angle is in the rare medium, that should be in the numerator. So in this case, because the angle of refraction will be in the rare medium, that should be in the numerator. Let me show you my work. I've done this, and let me increase the size. So the formula will be sine R divided by sine I equals to N. Why I put the R upstairs? Because the angle of refraction is formed in the rare medium, and that's a rule that should be upstairs. So sine R, which is basically question, sine 30, and the value of the angle of incidence is 30 equals to 1.8. And then do the calculation. The R value will be 64.16. The value of the R will be 64.16. I hope you can do this on the calculator. 64.16 will be the angle of refraction. So let's check. 64 point something, or D is the choice. I hope you have understood. The marking scheme also says D. Question number 21. D is the right option, sir. Question number 22. A musical note is produced by the two sources if he traces, if, sorry, the trace produced by each source on the screen of a cathode ray oscilloscope, CRO, are shown below. What is the difference between these two sounds? You can see these two sounds, they have the same time period. So it means they have the same frequency. Their amplitude is same. So it means the loudness is same. If their frequency is same, they will have the same pitch. The one thing which is different in them, the basic shape of the wave, the fundamental shape of the wave is different from each other. So we call this quality. So these two sound waves, they have the same time period, they have the same frequency. So it means they have the same pitch, they have the same amplitude, which means they have the same loudness. The only thing different in them is the fundamental shape, or the basic shape of these waves is different from each other. So that is called quality. What is the difference between the sounds? The quality. D is the right choice. Question number 22. D is the right choice. Question number 22. D is the right choice. The marking scheme also says D. So now on your screen, we have question number 23. Let me increase the size. What is suitable metal for the core of an electromagnet? The core of the electromagnet is always made from the soft iron. The core of the electromagnet is always made of the soft iron. So C is the choice. Question number 23, C is the right choice. Question number 23, C is the right choice, sir. Question number 24 is showing on your screen. A polythene rod becomes charged when rubbed with a dry woolen cloth. The charge caused is a result of. A polythene rod becomes charged when rubbed with a dry woolen cloth. The charge caused is a result of. This happens when you rub two insulators together. So due to this, due to the friction, the energy given by the friction, the electrons move from one point to another point, from one body to another body. So that's the answer. A friction producing a movement of electron, that is 100% the answer. So A is the choice basically. I made a mistake. Okay. So A is the choice. I think question number 24, A is the right choice. The correct answer was A option. When you rub them due to friction, the electrons have moved. So question number 25. A positively charged insulated metal sphere is brought close to an uncharged insulated metal sphere. So this one is basically positively charged. This one is positively charged, and this is uncharged. So due to the presence of this positive charge, what will happen? The electrons here, the free electrons here will be disturbed. So because this is positive, so that some electrons will accumulate here. they will be attracted because to this positive. So this end of this will become negative and this end will become positive. The important thing is the negative and the positive, they will appear on this left sphere, and sorry, this right sphere. Sorry, I said left. It's right sphere, and they will be equal in magnitude. The number of positive and negative should be equal. So I think B looks the best option, sir. This should be the situation. Question number 25, marking scheme also says B. B is the best option. The flash on a camera operates when a capacitor discharges through a flash tube in 3.2 millisecond. 3.2 millisecond. A charge of 6 coulomb passes through the flash tube. What is the average current in the, he says, what is the average current in the flash tube? What is the average current? I is equals to charge divided by time. Very simple. I equals to charge divided by time. The charge value is given, the time value is given. You just have to do the calculation. So on your screen, I think it's visible to you. You know, question number 26, I equals to Q divided by T. The charge value is 6. The time in this formula, time must be taken in seconds. The time should be taken in seconds. The time is 3.2 millisecond. Milli means 10 raised power minus 3. So 6 divided by, on your calculator, you can write this 6 divided by 3.2 expo minus 3 equals to. So it will be 1875, which is approximately 1900 ampere. 1900 ampere. Question number 26, 1900 ampere. Let me check the, do we have the, oh yeah, D is the option, sir. Question number 26, D is the right option. So next question is on your screen, 27. Question number 27. Let me increase the size if we can. Okay. Which physical quantity is produced by a calculation where a charge is multiplied by a potential difference? A very tricky question. Which physical quantity is produced by a calculation where a charge is multiplied by a potential difference? Let me show you. I've done this on a paper, and you can mark this question as a star. It's not easy. Okay, so he's talking about charge multiplied with the potential difference. So charge is Q and the potential difference is V. The charge, according to the equation of the current, I equals to Q divided by T. The famous formula, I equals to Q divided by T. If I will make the Q alone, it will be I multiply T. So in the place of this Q, I will put I multiply T multiply V. So little rearrangement IVT. You remember IVT? That is electric energy. So IVT is electric energy. It means that when you multiply charge with the potential difference, when you multiply charge with the potential difference, that is equals to the electric energy. Charge multiply potential difference equals to electric energy. So look at the options we have. Let's look at the options. Energy, C is the right choice. Question number 27, C is the right choice. But you should also understand that how I came to know that this is equals to energy. I've shown you that work. Kindly never forget that. Here we come. Question number 28 is on your screen. 310 ohm resistors are connected together to form a network X and Y and Z. So in the network X, the three are connected in parallel to each other. In network Y, they are connected in series to each other. And in the network Z, it's a combination. These two are connected parallel to each other, and then their resultant will be connected in series with this 10. So the question is, what is the order of resistance of the networks going from the smallest total resistance to the largest total resistance? First of all, smallest, then medium, then largest. This is the, so I have to calculate the total resistance for each combination. They want the total resistance for the network X, the total resistance for the network Y, and the total resistance for the network Z. So let me do this. I've done this on a paper. Let me show you my work. So we increase the size a little bit so you can see this clearly. So hopefully this is showing on your screen the network X, because these three resistors, they are connected parallel to each other. So I can find their equivalent resistors. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Just put the values, do this calculation, and the R equivalent will be 3.3 ohm. So for network X, the total resistance, the combined resistance is 3.3 ohm. For the network Y, the resistors are connected in series with each other, and their R equivalent can be found by the formula R1 plus R2 plus R3. Just put the value, you get 30 ohm. So the total or the equivalent resistance for the network Y is 30 ohm. The network Z is little bit complicated because here the R1 and R2, they are connected in parallel to each other. So first of all, I will find their equivalent resistance and I will call it R4. So 1 by R4 is equals to 1 by 10 plus 1 by 10, 2 by 10, cross multiply 2R4 is equals to 10. So R4 will be 5 ohm. This R4 is connected in series with the R3. So the R equivalent for the whole resistor, whole combination or whole network will be equals to R4 plus R3. That will be 5 plus 10, that is equals to 15 ohm. So the R equivalent will be 15 ohm. Now, what is the smallest resistance? That is X. Then we have Z, and then we have Y. X, Z, and Y. X, Z, and Y. I hope that this is clear to you. Okay, so we have X, Z, X, Z, and Y. I think the B is the best option, sir. Let me check the marking scheme. The marking scheme, question number 28, B is the right option, sir. I hope you have understood this. Which circuit contains a fuse and a diode? So this is diode, but it does not have a fuse in it. It has a fuse, but it does not have a diode in it. This, it has a light emitting diode, but it does not have a fuse in it. Here I have a diode, this is diode, and this is fuse. So D is the option. Very simple question. Marking scheme 29, D is the right option. Yes, sir. Hopefully you have understood this. Very simple question. Four resistors of unequal resistances are connected to a power supply as shown. The currents in the four resistors are 1 ampere, 2 ampere, 3 ampere, and 4 ampere. Which equation is correct? Okay. So let me increase the size so you can see it more clearly. You see the I1 current is coming from the battery and I4 current is going back to the battery. So I1 and I4, they are equal to each other. The amount of current which comes out of the battery, the same amount of current goes back to the battery. So I1 and I4 are actually equal to each other. Here you can see that I1 is splitting into two branches. So I1 is equals to I2 plus I3. And here they are combining back and they form I4. So I4 will be equals to I2 plus I3. I4 will be equals to I2 plus I3. So let me check the answers. I4 is equals to I2 plus I3, or D is the best option, sir. D is the best option, I think. I think D is the best option, sir. Question number 30, marking scheme says D. Let me reduce the size a little bit. Okay, which diagram shows a lamp wired correctly to the main supply in a house? So this is alternating current is connected here. So this is the live current coming, and from here this will go back to the neutral wire. So here they have connected switch and fuse. Remember this thing: the switch and the fuse, they are always connected in live. The fuse and the switch, they must be in the live. If you put them in the neutral wire, if you put a switch in the neutral wire, if you put a fuse in the neutral wire, if you put both of them in the neutral wire, this is wrong. We don't go like this. This is not safe. uh, the fuse and the switch, they both should be in the live wire. So where we have the options, D is the question number 31. C is the right option. I from the marking scheme, I'm telling you, C is the best option. I'm checking from the marking scheme as well. Here we go. Okay, need to reduce the size. P and Q represents two parallel straight wires carrying currents into the plane of the paper. P and Q exert a force on each other. Which row shows the force on the Q? You see, if you have two conductors, if you have two straight conductors like this, and the direction of the current in them is same, if the direction of the current in both the parallel conductors is same, they will attract each other. For example, if in both of them they are parallel to each other and the current is going, for example, downward like this, they are parallel to each other. Or for example, if you have two conductors, straight conductors, if they are like this and the direction of the current in them is same. For example, here P and the Q conductor on the diagram which is showing on your screen, the P and the Q conductor, they are two straight conductors and the direction of the current in both of them is into the page. If the direction of the current in both of them is same, they will attract each other. So the Q should be moved or attracted towards the P. The force on the Q should be towards D is the best option, so they can be attracting. Question number 32, D is the right option, sir. Question number 32, D is the right option. Okay, the diagram shows a simple DC motor. The diagram shows a simple DC motor. Which part is labeled Q? Which part is labeled Q? Let me show you that. Which part is labeled Q? Which part is labeled Q? This is called split ring commutator. This part is called, the Q thing is called split ring commutator. Split ring commutator. So I think, let me. So what is the Q? The Q is a split ring commutator. Commutator B. B is the best option, sir. Question number 33, B is the right option. Question number 34, an experiment is set up to investigate how the current in the filament lamp changes with the potential difference across it. Current in the filament lamp changes with the potential difference across it. Which circuit is correct? Okay, let me reduce the size so you can see whole circuit, all the circuits, the 4 circuits he has shown. Okay. So this ammeter is not reading the current which is flowing through the lamp. So I'm not interested in this. Oh, this diagram looks the best because it is measuring the current which is flowing through the lamp and it is also taking the voltage across the lamp. So B can be the answer. This diagram cannot be the answer, the C one, because it's not measuring the voltage across the lamp. It's measuring voltage across the lamp and the thermistor together. This one is wrong because it's measuring that because here you see you have connected a voltmeter which is in series with the variable resistor. That's the wrong thing. So B is the right option, sir. B is the right option. B is the right option. The best diagram by which you can measure the voltage across the lamp and the current which is flowing through the lamp. And here he has used a variable resistor. So by moving this sliding contact to the left or to the right, you can change the resistance of this variable resistor. So B is the best option for question number 34. B is the best option. The marking scheme also says B. Okay, on your screen now we have question number 35. An electric power cable transmits electric energy over large distances using high voltage alternating current. What are the advantages of using a high voltage and of using an alternating current? It's a famous question. Sometimes this question comes in the theory paper. It has many times came in the theory paper, and you have to write this answer. Why we are using a high voltage? Because it reduces the energy loss in the cables. Why we make the voltage high? And because it makes the energy loss in the cables less. Advantage of using an alternating current: we are using alternating current in the transmission lines because the transformers, they can only work on the alternating current. So you can use the transformer. So I think the D will be the best option. And don't forget these wordings, because sometime in paper 2 you will have to write this wording which I have just made yellow. Less energy is wasted in the cable and the voltage can be changed using a transformer. So D is the option. Question number 35. D is the right option, sir. A very simple question, but the diagram is such that you might get confused. Which section of the circuit contains a potential divider? In the potential divider, we have two appliances, two resistors connected in series with each other, and we take V out from one of them. Either you can take the V out from the first resistor, or you can take the V out from the second resistor. Potential divider is basically two resistors which are connected in series with one another, and we take V out from across one of the resistors. Either you can take the V out from the R1 or you can take the V out from the R2. So clearly the potential divider is here. B is the right option. The potential divider is in the section B. There are two resistors which are connected in series with each other, and across one you have taken the V out. So B is the choice. Question number 36. B is the choice. The marking scheme is also saying B. I hope you have understood. So we have question number. Okay. Well, I need to reduce the size a little bit. Okay. Which particles are emitted by the hot filament of a cathode ray oscilloscope CRO, and which type of field is used to accelerate them? You see, from the hot filament, electrons are given out, and this process is called, thermonic emission. We call this thermonic emission. When you make a cathode or a metal very hot, or you made a cathode which is made of metal very hot, what will happen? The electrons from that metal will come out into the air. Electrons will come out into the air from that metal. This is called thermonic emission. This process is called thermonic emission. So the particles which are coming out of the hot metal, hot filament are electrons. And then we put in front of them an anode. We put an anode in front of them. And that anode, which is a positive electrode, we put an anode in front of them, and that positive anode is at very high voltage. And what that positive anode at very high voltage do, it attracts those negative electrons. So the electrons will be accelerated. This is the story of a CRO tube. So you see, the particles which are given out from a hot filament, they are electrons. And to accelerate them, we use electric field. So I think is the choice. The particles are given out, they are electrons, and the type of field is electric field. So very simple. Question number 37, A is the right choice, sir. The marking scheme also says A. Now question number 38 is on your screen. It's little tricky. In the circuit shown, all lamps are identical. Lamp P lights with normal brightness. Switch Y is closed and the lamps come on. Which row indicate the brightness of the lamps? You see, when this is working on normal brightness, when you will close this switch, so this and these two, they will be parallel to each other. Okay. Now you see the voltage drop, because they are parallel to each other. The voltage drop in this branch will be equal to the EMF of the battery, and the voltage drop on this branch will be also equal to the EMF of the battery. But here in this branch, you have only one lamp. Here you have only one lamp. So the voltage will be available to this lamp P. But in this branch, the total voltage drop will be equal to the voltage of the battery, EMF of the battery. But in this branch, these two are in series with each other. So half of the voltage will be taken by the R, half of the voltage will be taken by the Q. So they both, as compared to the lamp B, are getting half the voltage. So this will be at this normal brightness, and because they do these two, they are getting the half the voltage, so they will be dim. So I think the P will be normal, and the Q and the R, they will be dim. So it looks to me that the B is the right option, sir. B looks the right option, sir. According to the marking scheme 38, B is the right option. I hope you have understood. It's little heavy question. So here comes the question number 39. Which type of electromagnetic radiation is produced during the radioactive decay? The electromagnetic radiation. There are three types of radiations in our course. One is alpha particles. They are like helium nucleus. Then we have beta, which is like negative electrons. And then we have gamma rays. Gamma rays are basically electromagnetic rays. They are electromagnetic waves, gamma rays. And if you remember the chapter of electromagnetic spectrum, Ronald McDonald is very ugly except Gary. Gary stands for the gamma rays. So the gamma rays is that the particle or the radiation which is given out, and it is electromagnetic. C is the choice. Electromagnetic. Gamma rays are electromagnetic. Question number 39, C is the answer. The marking scheme also says C. We are moving to the next question. That's question number 40. Which row states where nuclear fusion occurs and what nuclear fusion is? You see, in the nuclear fusion, what happens? Smaller hydrogen nucleus, small hydrogen nucleus, they come close to each other and they fuse into each other and they make a large nucleus of helium. And this process is called fusion, and this is happening on the star, this is happening on the sun. So smaller nuclei join to make a larger nucleus. So look at the options given to you. What will be the right option? He says power station. This process do not happen in the power station. A star, yeah, a star. C and D can be the option. The joining of small nuclei, yes, sir. This is the nuclear fusion. And splitting of the large nucleus. The splitting of the large nucleus, is known as fusion. This is fusion. So C is the choice. Question number 40. C is the choice. So now we have done this paper. Let me, yeah. So today in this video we have done October November 2015 1 month paper. Students, it's a MCQ paper, and this is from the zone 1, or you can say variant 1. And I've done my best through my paperwork and through my descriptions. I can make your concepts clear. The best way of learning is that you should have a hard copy of this paper. You can buy, you can order, you can print the hard copies of these papers, and you take the hard copy and you sit in the front of the computer and you play these videos, and you also do the work on your hard copy. So I hope that this video is helpful to you, and is helping you to improve your concept. If these videos are helpful to you, kindly subscribe my channel. Also like this video, and if you have any kind of comments, please comment. And I will, because your feedback is very important for me. Your feedback is kind of energy for me, and I will work more and more. So thank you very much, everybody, and have a good day. God bless you all. My name is Ferhan Mazher. Thank you very much.